When we are using the sine and cosine rules, our convention for labeling triangles is that we will use small letters for the sides and capital letters for the corresponding or opposite angles of those sides. So for example, in this triangle here, if we call this side small a, then we will call the angle over here capital A. So small a corresponds to capital A, or small a is opposite capital A. Now, let's take another side. Let's look at this side here. We can call it small b. If this side is small b, then the angle corresponding to it is this angle here, which we call capital B. Finally, we can call this third side small c. Then this angle here is capital C. The sine rule says that a divided by the sine of a equals b divided by the sine of b equals c divided by the sine of c. Let's look at this example here. We're going to find the missing side of this triangle. When we're looking for the side of a triangle, we call it small a. Well, we could call it small b or small c, but it's just a convention that I will use. I will call a missing side small a. If this side is small a, then this angle over here is capital A. We can find capital A because the three angles in a triangle sum to 180 degrees. Capital A must be 50 degrees because 50 plus 60 is 110 degrees, and if we add on 70 we get 180 degrees. Now we call one of the other two sides small b. It doesn't matter. Let's call this side small b. If this side is small b, then the angle that's opposite this side must be capital B. So this angle must be capital B. Of course, the side that's remaining must be small c, and the angle that's remaining must be capital C. Now in practice we don't need to work with c. We don't have to work with this side or this angle. We have enough information to find small a. So in practice we're just using this part of the sine rule, although it's true of course for all three sides and all three angles. So all that's missing is small a. To find small a, we have to multiply both sides by sine of a. So small a is b sine a divided by sine b. So I've just multiplied both sides by sine of a to get rid of this denominator, and we're left then with small a, which is what we want. And we can just fill in the values. Small b is 9. Sine capital A, well, capital A is 50 over sine capital B is 60. Go to your calculator, make sure it's in degree mode. We have 9 times the sine of 50, and we must divide it by the sine of 60. So to the nearest integer we get 8. I'll round this to 2 decimal places, get 7.96. Here I've just color coded the sides with the corresponding angles. Notice that we didn't have to use the side labelled small c and the angle labelled capital C. But if we take small c and divide it by capital C, we should get the same as, say, small b over sine of capital B. Small c over sine capital C is 8 divided by the sine of 70 degrees. To 2 decimal places you will get 8.51. If we take small b over sine capital B, we have 9 divided by the sine of 60. You can check that you will also get 8.51. So the three ratios are the same, and a over sine a is also. I'll write down a over sine a. Now in this example we have a right angle triangle. The right angle is angle YXZ. We are interested in the distance between the points X and Y. Now, what I will do is I will call the side that we are looking for small a. If I call this side small a, then capital A is the angle corresponding to it, or the angle opposite small a, which is 32 degrees. Now we need a side. Well, this is the only side we have, this side XZ. So we'll call this side B. And if we call this side B, then capital B is opposite small b. Capital B must be up here. And we can work out B because the three angles sum to 180 degrees. So we take 180 and subtract off the two other angles. We get 58. So from the sine rule, we know that A over sine A equals B over sine B. And we don't have to bother about the third side. This third side would be small c, and capital B would actually be 90 degrees. Or sorry, not capital B, but capital C would be 90 degrees. So we only just use the first two ratios in the sine rule for solving problems. So we need to get small a. So like before, we just multiply across by sine a. Multiply both sides by sine a. We get this. And we plug everything in. So small b is 6. Capital A is 32 over sine of capital B, which is 58. To two decimal places we get 3.75. Now we could have done this question another way, using our ratios of sides for right angle triangles. We can see that the side that we're looking for is opposite 32 degrees. And the side that we're given is adjacent to 32 degrees. We know that the tan of 32 degrees is the side opposite 32 degrees in this right angle triangle, divided by the side adjacent to it, which is 6. So from this equation, we can see that the side opposite 32 degrees is 6 tan 32. And if we work out 6 tan 32, we should get 3.75. So that's the tan of 32 degrees. We multiply it by 6. And as you can see, to two decimal places, we get 3.75. Now in this example, we're going to see how to find an angle. In this triangle XYZ, we are going to get angle XYZ. So one arm of the angle is XY, the other arm is YZ. So angle XYZ is this angle here. We can see that Y is at the vertex of the angle. That's the letter in the center. So we can call the missing angle capital A, capital B, or capital C. It doesn't matter, but I prefer to call it capital A. I prefer to use the letter A for a side or an angle that we are looking for. So we're looking for an angle, so I'm using capital A. If this angle is capital A, then the side opposite capital A is small a. Now we need small b and capital B. Well, the only side that we're given is this side here, so we've no choice but to use this side. So we call it small b because it's a side. If this side is small b, then the angle opposite small b is capital B. So we apply the sine rule to two sides and the corresponding two angles. We ignore the third side. This side here would be small c, and capital C would be this angle here. That doesn't come into using the sine rule. We need to find A. So we need to get sine of A on its own. Now, because we have a single fraction on each side, we could cross multiply. We could say a sine b equals b sine a and rearrange to get sine a. Well, that's one way of doing it. What I will do is turn both of these fractions upside down. If we have one fraction equal to another fraction, turning them both upside down or getting the reciprocals of them doesn't change. This is still true. Sine a over a equals sine b over b. And to get sine of a now, we just multiply across by a. So if we multiply the left hand side by a, we get sine of a. If we multiply the right hand side of a by a, we get a sine b divided by small b. So we plug in our values. Small a is 9. Capital B is 65. Small b is 8.5. If we work this out to 4 decimal places, we get 0.9596. I wrote it down to 4 decimal places because we need to get angle A, so we need to take the inverse sine or the arc sine of 0.9596. Now in this calculator, you can see sine of A to many decimal places, so I will just get inverse sine of this number. And to 2 decimal places, we get 73.66 degrees. When we took the inverse sine of 0.9596 using the calculator, we got one answer, 73.66 degrees. But we know that there are actually two answers. There is an obtuse angle, that is an angle between 90 and 180 degrees, whose sine is 0.9596. We know from previous videos on the unit circle that a point on the unit circle has coordinates cos theta sine theta, where theta is measured anti-clockwise from the positive x-axis. So if the angle is 73.66 degrees, then the y value of this point on the unit circle, that's a circle of radius 1, is going to be 0.9596. So this number here is 0.9596. And we know that if we reflect this point through the y-axis, we have a point on the unit circle whose coordinates are going to be got by negating the x value, but the y value is going to be the same. So the y value of this point here, got by reflecting this point through the y-axis, is also 0.9596. But we are talking about this angle here. So the coordinates of this point are got by getting the cos and sine of this angle. This is an angle that's obtuse between 90 and 180. We saw before how to find this angle. The reference angle is 73.66 degrees. That's the angle in here. So we take this angle from 180 degrees and we get 106.34 degrees. So we see that the sine of 106.34 degrees is also 0.9596. So there are two answers. So that means that there are two possible triangles. In this triangle here, this angle is the same as this angle, 65 degrees. XZ is 9 units long, just like here. However, angle XYZ is an obtuse angle. It's 106.34 degrees. YZ here is 8.5. Here I'm showing triangle XYZ as part of our original triangle XYZ. This dotted line is the same length as this side here, it's 8.5. Of course, if we're working with this new triangle XYZ, then this is our angle A in here. This angle here is the same as this angle here, because these two sides are the same. This is 8.5, this is 8.5. The two sides are the same, then the two angles in the base of this triangle here are the same. This angle we know is 73.66. Then this angle here is also 73.66. So that's the external angle of our new triangle XYZ. So There are two possible triangles that fit the description of triangle XYZ. Two possible triangles that have sides of length 9 and 8.5, where the angle opposite 8.5 is 65 degrees.